bucka. Ha. You know the deal.
Before we look at solving equations with fractions in them, let's just take a quick look at how to solve equations with division. Because a fraction really is division. And for our question here, what we're being asked to do here is to solve this equation. So of course our goal is to isolate the variable. Well, what do we have to get rid of to get the variable by itself? Here is divided by 2. And as we've seen in all the previous examples, to get rid of divided by 2, we do the opposite. So we would multiply by 2. So if we multiply one side by 2, we have to multiply the other side by 2. Now, what happens on the left side is multiplying by 2 and dividing by 2 cancel themselves out, and we get the solution x equals 10. This property that we did over here is a very important property when we're dealing with questions, algebraic equations that involve fraction. So here we have an example of an algebraic equation that does involve fractions. Just like all other algebraic equations, our goal here is to isolate the variable to get x by itself. What makes this a little bit more complicated than previous examples is we do have some fractions to deal with here. So what we're going to talk about next is how to deal with these fractions. The first thing we want to do when we have any question, any algebraic equation with fractions in it, is we want to have a common denominator. So we have to look at our denominators here, which is 2, 3, and 4, and ask ourselves, well, what is a common multiple of 2, 3, and 4? What's the lowest common multiple of 2, 3, and 4? And hopefully you understand that our lowest common denominator here is 12. That's the first number that would be a multiple of 2, that's also a multiple of 3, and a multiple of 4. So we want to make it so that each of the denominators here is 12. So we have to ask ourselves, well, we've changed 2 to 12 here. How did we do that? Well, we multiply it by 6. That's how we write equivalent fractions. We write equivalent fractions by either multiplying or dividing. So to change that 2 to a 12, we had to multiply it by 6. If we multiply the denominator by 6, of course we have to do the exact same thing to the numerator. So the equivalent fraction here is 6x over 12. Because we multiplied the denominator by 6, we have to multiply the numerator by 6. Similarly, with the next one, our denominator was 3. To change that to 12, we multiply it by 4. So that's what we have to do to 1. We have to multiply it by 4. With the fraction on the right-hand side, to change 4 to 12, we have to multiply it by 3. So that's what we have to do to 1 here, multiply it by 3. So now we have a case where we have the same denominator for each term. As we saw with the previous example, if we wanted to get rid of over 12, we would times by 12. Well, the thing is if we times one term by 12, we have to times every term by 12. By doing that, multiplying by 12 and dividing by 12 essentially cancel themselves out. So when you have the common denominator, those denominators are all gone because we multiply each term by that denominator. And now we've got an equation where we have 6x plus 4 equals 3. No more fractions. So first thing we're going to do is bring this plus 4 over to the other side. 6x equals 3 minus 4. We have a case now where we can simplify. 6x equals negative 1 because 3 minus 4 is negative 1. We have to divide both sides by 6. And now we can simplify the left-hand side. Multiplying by 6 and dividing by 6 cancel themselves out. With the right-hand side, we really just have a fraction. And it is in simplest form already, so we would just leave our answer as a fraction, negative 1 over 6. Here's another example where we've got an equation that we're being asked to solve. So again, we have to isolate the variable. But like the last one, this equation does have some fractions in it. So our first step is we need to rewrite this equation so that we have a common denominator. Now, you'll notice right off the bat here that on the right-hand side, we just have 2. That's not written as a fraction yet, but we need all of the terms to have a common denominator. So in other words, we need to write 2 as a fraction. Anytime you have a whole number, and you want to write it as a fraction, it's over 1. 2 over 1 means 2 divided by 1, and 2 divided by 1 is the same as 2. So 2 is the same as 2 over 1. So now we look at the denominators, 3, 5, and 1. Our common denominator there is going to be 15. That's the first multiple of 3. That's also a multiple of 5. That's also a multiple of 1. So again, we have to ask ourselves, well, how do we rewrite equivalent fractions? How do we change 3 to 15? We have to times it by 5. So that's what we have to do to the numerator as well. We have to multiply y times 5. Well, y times 5 is always written as 5y. That's how we write y times 5, or 5 times y. For the next fraction, we multiplied the denominator times 3, so that's what we have to do to the numerator. And for the last one, of course, we multiplied the denominator times 15, so that's what we have to do to the numerator. So now we've got the same denominator on every term in this algebraic equation. What we're really doing here now is we're multiplying each term times 15. And what happens is those 15s disappear. Now remember, it's not magic. They're not just disappearing, but mathematically we're multiplying each term times 15. Multiplying by 15 and dividing by 15 cancel themselves out. Well, now we've got an equation where we don't have any more fractions in it, so we just have to go about isolating the variable. Bring that plus 3 over to the other side, it becomes minus 3. We've got something here now that we can simplify. 30 minus 3 is 27. Still have to get rid of that times 5, so we divide by 5. If we divide one side by 5, we have to divide the other side by 5. And again here we've got a fraction. 5 doesn't go evenly into 27, so it's good enough to just leave it as 27 over 5. As long as the fraction is in simplest form, you can leave that as your final answer. Here's an example where once again we're being asked to solve this algebraic equation. So our goal is to isolate the variable. Well, again, we've got an equation where we have fractions involved. So our first goal here is let's get rid of those fractions. To get rid of the fractions, we have to find a common denominator. Our common denominator in this case is 12. So we're going to change those denominators, so instead of being 3 and 4, they're both 12. So again, you have to ask yourself, well, how do I change 3 to 12? I have to times it by 4. Now the thing here is we have to multiply the whole numerator times 4. So we're going to multiply 4 times everything in the numerator. And on the right hand side, we change 4 to 12 by multiplying it by 3. So that's what I have to do to everything in the numerator. The whole numerator has to be multiplied by 3. Well, now that every term has a common denominator, basically we're just multiplying both of those terms times 12, and those 12s disappear. So now we've got an equation where, again, we have to solve this. But here there is some simplifying we can do. If you have an algebraic equation and there's some math that you can do there, you can do that math. So as we've seen already in grade 9, what we have here is what's called our distributive law. We're multiplying 4 times everything in the brackets. So 4 times x is 4x, and 4 times positive 2, or 4 times plus 2, is plus 8. On the right hand side, 3 times x is 3x. 3 times plus 5 is plus 15. So now we've got something where we've got to bring our x's over to one side and our numbers over to the other side. When we bring that 3x over to the left hand side, it becomes minus 3x. We have positive 15 still on the right hand side. When we bring that plus 8 over, it becomes minus 8. Now 4x minus 3x, nice thing here is that's 1x. 1x is just the same as x. Positive 15, or 15 minus 8, is 7. So we've done it. We've got x by itself on one side of the equal sign. Now that we've seen these types of questions a couple of times, I want you to go ahead and try a few of these on your own. So what I'd ask you to do now is pause the video, go ahead and solve each one of these equations. And remember, the first step here is get your common denominator, and then go ahead and isolate the variable. So give each one of these a shot after pausing the video, and then if you want to see the full solution, go ahead and press play. Alright, let's take a look at the first one. So with the first one, our first goal here is to get a common denominator, and hopefully you realize the lowest common denominator here is 4. So we need to make it so that all of the denominators are 4. Well, with the first one, you ask yourself, how do you change 2 to 4? When we're writing equivalent fractions, we only multiply or divide, so to change 2 to 4, we would multiply it by 2. So that's what we have to do to x as well. Now with the other ones, the denominator was already 4, so we don't actually have to change the numerators here at all. So now we've got a case where we can cross out all of those denominators. Once the denominator is the same for all of the terms, the denominators disappear. So what we're going to do here is go ahead and now just isolate the variable, bring plus 1 over to the other side, so we have 2x equals 3 minus 1. We can simplify that. 3 minus 1 is 2, so we have 2x equals 2. Divide both sides by 2, and you end up with x equals 1. For the next one, the first step you probably want to take here is to write 2 as a fraction. 2 as a fraction is just 2 over 1, and now our common denominator is 15. So we're going to rewrite each one of the terms so that 15 is in the denominator. Well, to change 5 to 15, we multiply it by 3, so that's what we have to do to x. To change 3 to 15, we have to multiply it by 5, so that's what we have to do to 1. 1 times 5 is 5. And to change 1 to 15, we have to multiply it by 15, so that's what we have to do to 2. Now these denominators are gone. So we have the equation 3x plus 5 equals 30. We can go ahead and isolate the variable by bringing that plus 5 over to the other side first. And we have 3x equals 30 minus 5. When we bring that plus 5 over to the other side, it becomes minus 5. We simplify that. We get 3x equals 25. And we still have to isolate the variable, so we divide both sides by 3. And now we have a fraction as our final answer. 25 over 3 is as simplified as it can get, so we can leave that as our answer. For the last one, again, we need to find a common denominator, and hopefully you realize that the lowest common denominator is 6. The first multiple of 2 and 6 that's the same is 6. So with the left-hand side, to change 2 to 6, we have to multiply it by 3. So that's what we have to do to everything in the numerator there. Now, of course, with the right-hand side, we didn't change the denominator at all, so we don't have to change the numerator at all. It stays exactly the same. Now all of the terms have the common denominator, they're gone. So now we can go ahead and simplify. Do our distributive law there. 3 times x is 3x. 3 times minus 5 is minus 15. On the right-hand side, we still just have x plus 7. We bring all our x's to one side. That 3x stays the same. Bring positive x over to the left-hand side, it becomes minus x. We still have positive 7 on the left-hand side. Bring minus 15 over to the right-hand side, it becomes plus 15. 3x minus x, or 3x minus 1x, is 2x. 7 plus 15 is 22. Divide both of those sides by 2, and we get x equals 11. If those were the solutions that you got to these 3 questions, congratulations, you now have a firm understanding of how to deal with equations that involve fractions.